Good afternoon everybody. Today we are going to give a lesson on cache memory. We are the group of two members, myself Tapuchi Bhattacharjee and my partner Aparajita Chaudhuri. First, I'd like to explain about memory hierarchy pyramid. The memory hierarchy pyramid actually consists of few memory items within memory and the system, means CPU. The top one is the registers, then is the cache memory, then main memory, then secondary memory, and lastly the offline storage. As registers are the part of CPU where the data is brought during the execution of a program. Cache memory is placed in between main memory and registers. Then for permanent storage, the data is kept into secondary storage, and from there it is kept into offline storage, that is magnetic tapes. As we know, the performance of memory increases upward direction as per their cost and speed, and it decreases in downward direction as per their size and capacity. Now, where cache memory is required, when a program references a memory location, it is likely to reference that same memory location again soon. A memory location that is near a recently referenced location is more likely to be referenced than a memory location that is further away. Cache memory is a small and fastest memory which is kept in between CPU and main memory. When our data is required by the registers, it is being searched in the cache memory. If the data is present in the cache memory, then this situation is called cache hit. If it is not present over there, then this situation is known as cache miss, and in that case the main memory is searched and accessed, and then it is brought first to the cache memory and then from cache to the registers, and similarly after execution of the operation same process is being followed. The time required if a cache miss occurs in the system, then the time required to execute or to search the main memory is known as miss penalty. Next, what is hit ratio? Hit ratio is basically the ratio of cache hit divided by cache hit plus cache misses. That means, suppose in a system hit ratio is 80%, then if 100 items are being taken, out of those 100 items, 80% times it is the cache hits and 20% time will be cache misses. Why cache memory is fast? Because it is faster electronic devices are being used. Cache memory has fewer locations than a main memory, which reduces the access time. The cache is placed both physically closer and logically closer to the CPU than the main memory. The cacheless computer usually needs a few bus cycles to synchronize the CPU with the bus. A cache memory can be positioned closer to the CPU. Next, my friend will be telling you few points about different cache mapping techniques.
Hello, good afternoon. Myself Aparajita Chaudhuri. As we know, cache mapping is commonly divided into three parts. First on associative memory mapping, then direct mapping, and then set associative mapping. Now, in associative memory mapping, as you see in the diagram, any main memory blocks can be mapped into each cache slot to keep track of which one of the 2 to the power 27 possible blocks is in each slot. A 27-bit tag field is added to each slot. Now, valid bit is needed to indicate whether or not the slot holds a line that belongs to the program being executed, and dirty bit keeps track of whether or not a line has been modified while it is in the cache. Now the mapping from main memory blocks to cache slot is performed by partitioning an address into fields as is shown in the figure. The tag field is of 2 to the power 7 bits and field is of 5 bits. Now for each slot, if the valid bit is 1, then the tag field of the reference address is compared with the tag field of the slot. Now how an access to the memory location is mapped to the cache? You can see from the diagram. Now if the address word is in the cache, it will be found in word of a slot that has a tag of 501AF80 16 bit, which is made up of the 2 to the power 27 most significant bits of the address. Now the advantages of associative memory mapping. Any main memory blocks can be placed into any cache slot regardless of how irregular the data and program referenced are. If a slot is available for the block, it can be stored in the cache memory. Now also there is some disadvantage of associative memory maps, which are those: considerable hardware overhead needed for cache bookkeeping, and another one is there must be a mechanism for searching the tag memory in parallel. Now the next one is direct memory mapping. In direct mapping, each cache slot corresponding to one explicit set of main memory. Now in our example, in the diagram, we have 2 to the power 27 memory blocks and 2 to the power 14 cache slot. Now a total of 2 to the power 27 divided by 2 to the power 14, which is equal to 2 to the power 13 main memory blocks can be mapped onto each cache slot. The 32-bit main memory address is partitioned into 13-bit tag field followed by a 14-bit slot field and followed by a 5-bit word field. So the direct mapping, the total field is divided into 3 parts: tag, slot and word. When a reference is made to the main memory address, the slot field identifies in which of the 2 to the power 14 slots the block will be found. If the valid bit is 1, then the tag field of the referenced address is compared with the tag field of the slot. How an access to memory location is mapped to the cache. If the addressed word is in the cache, it will be found in word 1416 of slot 2F8016, which will have a tag of 140616 as is shown in the figure. Now the advantages of direct mapping is the tag memory is much smaller than the associative mapping, and no need for an associative search since the slot field is used to direct the comparison to a single field. And there is some disadvantages also in direct memory mapping. Consider what happens when a program references locations that are 2 to the power 19 words apart, which is the size of the cache. Every memory reference will result in a miss, which will cause an entire block to be read into the cache even though only a single word is used. Now in said associative memory mapping. In this mapping technique, as you find in the diagram, it combines the simplicity of direct mapping with the flexibility of associative mapping. Now in this example, 2 slots makes up a set. Since there are 2 to the power 14 slots in the cache, there are 2 to the power 14 divided by 2, which means 2 to the power 13 sets. When an address is mapped to a set, the direct mapping scheme is used, and then associative mapping is used within a set as you shown in the figure. The format for an address has 13 bits in the set field, which identifies the set in which the addressed word will be found. 5 bits are used for the word field and 14-bit tag field. As you shown in the figure, the total part is divided in 3 fields: tag, set and word. Now the advantages of set associative mapping. In our example, the tag memory increases only slightly from the direct mapping and only 2 tags needed to be searched for each memory reference. The set associative cache is widely used in today's microprocessor. Now my friend Taposhe Bhattacharya will continue the PPT.
Welcome back. Now I'll be explaining cache write and read policies. Basically, there are two types of cache write policies are there. One is write through and write back. In write through policy, when a cache memory is being updated at the same time main memory is being updated, and that means that cache updation and main memory updation occurs at the same time. And in case of write back policies, that it says that when the cache memory is being updated at the same time main memory will not be updated, it will remain unchanged. When the cache block is being replaced by the main memory block, then then only the cache memory block will be changed. That means that main memory block will be changed at the end of the execution of the cache block. So this is the two policies of cache writing. So lastly, cache performance. As to which cache read or write policies are best, there is no simple answer. The organization of a cache is optimized for each computer architecture and the mix of programs that the computer executes. So I'll conclude over there. Thank you very much for this silent listening.